Okay, so let's talk about this problem. AMC 2010 question 30, yeah? Um, so it's a very interesting problem that we should have thought about for a long time, right? Middle primary, Australian Maths Competition, middle primary question 30, yeah? Okay, so if you're going to write a proof of this question, like when you get older, you can write proofs. You would say the answer first, and then you would explain why it's true, okay? So, but I'm gonna not say the answer until the very end, okay? So remember what the problem was? So you had this like 6 by 5 grid, right? And you draw a triangle. You draw a triangle with one corner here, yeah?
Yeah.
And one corner on this side of the top, and one corner on the side on the right, yeah? And the question asks you, what is the most number of squares that this triangle cuts, yeah? Yeah? You want to say something? Oh, did you have your hand up? Oh, okay, yep. Okay. So, I think this is a good question because it makes you think a lot, okay? Um, and I think if we try lots of different things, you'll see that some of the things we actually tried, it can turn into some very good ideas, okay? So, for example, can you see that if you have blue, let's do blue, let's do green. So if I draw green lines like this, yeah. You remember I did something like this last time, but we didn't really convert it into anything. Okay. So if I draw lines like that, right? What's the point of drawing a line like that? Okay, so if I have a red line, it goes like here. Okay, so that's the triangle, yeah? So what this does is, so basically what this does is, so if you look at, for example, each green line, okay?
Yeah.
Each green line has sort of a bunch of squares that it cuts through, right? And basically, the point I'm trying to make is, every green line. So this green line has 4 squares that it cuts through, right?
Yeah.
Okay, and however many times. So obviously, the red line can only cut the green line once, right? Okay.
Yeah.
So basically, what I'm trying to say is that the intersection of the red line with the green line, yeah, represents all the squares on that green line that the red line cuts. Does that make sense?
No.
Hmm? No.
I do not know maths.
Okay, so okay. Alright, Michelle, pay attention then, okay? Michelle. Hello? Michelle.
I'm almost done.
Almost done. What are you doing?
Drawing.
Drawing what?
Drawing a unicorn. Oh my goodness.
Why are you drawing a
Stop.
I see.
Is the unicorn cutting any squares?
Yeah. Yeah, is the unicorn related to this problem? How long till you're done?
1 second. Done. What? Why do you have to color that? There.
Okay, once you're done, can you have your complete attention now, okay? A
Okay.
blank piece of paper. Give her a blank piece of paper.
I got my unit. Oh, a blank pencil.
Oh, that's not blank. Get another one. Get that one. Wait. Get that piece of paper. Okay, now don't look at your unicorn anymore.
Or not look at my milk.
And give me the milk. Give me
No,
the
I
milk.
want to keep milk.
No, it's too distracting. Give me the milk.
No.
Alright, keep the milk. Put away the unicorn. Focus on the paper.
I'll
Okay.
put the milk here, and I won't look at the milk. And I'll put my unicorn here, and I'm not looking at my unicorn.
Okay, watch this, okay? Okay. So basically, see there's 4 squares on the green line with the blue dots, yeah?
Yeah.
Okay. And what the blue dots represent,
Looking.
look at it on the flat screen. So what the blue dots represent is the farthest.
A blue dot. There's no blue lines.
No blue lines. The green line with blue dots, yeah? The blue dots are the corners of the squares, right? You see that? And for the red line to hit that square at all, it has to go in between the 2 blue dots, right? Okay. So you can look at those blue dots, right? And it's obvious it can't go between the first 2 blue dots and the second 2 blue dots at the same time.
Whiteboard.
Right? Because it can only intersect the line once. Right?
I'm gonna get a whiteboard on my iPad.
Just watch this. No, just watch this, okay? You're being too disruptive. Just watch. Okay? Just watch.
Plus.
Okay. So immediately you know that out of these 4 squares, okay, this one side can only hit one of the 4 squares at most, right? Okay. And what else do you know? You also have, it's also very nice that before you were intersecting this one line with 4 squares, right? But now you're just intersecting it with the line and you get the same answer, right? So this is what's called a simplification, right? Simplification. It makes it simpler, yeah? Does that make sense? So before you were intersecting these 4 squares, yeah? Yeah?
Why are you drawing a staircase?
So I've basically replaced those 4 squares with one green line as far as this red line is concerned, okay?
That's not a square, that's a staircase.
Okay, stop. So you need to learn here, okay? You don't know anything, so you have to learn, alright? When you know more, we'll listen to you. Do you understand? Okay. Okay, does that make sense? So immediately, if you have 2 sides of this, so oops. So if you have like 2 sides of this triangle, right? Okay.
Yeah, but if you connect the triangle, you're gonna miss a bunch. Like that.
Yeah. So can you see every green line, right? Sometimes the green line has 1 square. Sometimes the green line has 2 squares, 3 squares, 4 squares. 5 squares is the most. And then it has 5 squares, and then it goes back to 4, 3, 2, 1, right?
And I have 6 squares.
So, but the red line can only intersect each green line once, right? So these 2 red lines can only hit 2 of the squares on each of the green lines. You understand what I'm saying?
No,
Yeah?
I don't.
So like, this red line can only intersect this green line here, 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 and here, right? So, where it intersects the green lines, exactly how many squares it cuts, right? So here it cuts 1, 2, 3, 4, 5 squares, yeah? So it's much easier to see where it hits the lines than to see which squares it cuts. So this makes it very much easier to think about. You understand? Okay, and similarly this side, it hits 1, 2, 3, 4, 5, 6, but then this square is counted twice because it's on the same green line, right? Okay. Okay. So if that was like the only two sides of a triangle, we don't have to worry about the third side. Then we've basically solved the problem, right? Because if we don't have to worry about the third side, yeah, then we just need to cut as many green lines as possible, right? Does that make sense? So then we would try to cut as many green lines as possible. If we cut all the green lines, okay, as long as we make sure that um, they're not they're on different squares. Um, so as long as we make sure that they're on as many different. So for example, this could cut 1, 2, 3, 4, 5, 6, 7, 8, 9, possibly 10 green lines, right? So like one, how do you do this? Okay. And then here you would cut.
Where are you going to show? Is it get paid? What I get? Yeah, what are you getting in the show? Something from the fridge? Definitely cheese. She always eats cheese. I guess.
Yeah, so
Concentrate, Michelle.
I mean, so the 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 green lines, right? And obviously, you don't need the second red line to cut the corner green line if the first one touches it, because that's only one square anyway, right? So so all you'd have to do is get one of them to try to cut all 10 green lines, right? And then you'd have the other one cut like these green lines. See? Because you don't need to cut this one because there's only one square anyway, right? So
Papa,
what?
this cheese is the size of one square.
You're being very rude right now. You understand? You should be watching this. Yeah. So so we definitely know, for example, like these two red lines, they can't cut more than 20, right? Together. They can't cut more than 20 because there's only 10 green lines. Yeah? Okay. But one of them can definitely cut 10, right? Because you can actually draw it to cut all 10 green lines. Okay. And the other one, okay, so the other one can definitely not cut um what would you say? The other one can definitely, so if the first one cuts 10, the second one doesn't need to cut 10 because the two corner ones are only single squares, right? So the other one would only need to cut like 8, yeah? Does that make sense?
I have a question.
Huh? So if you can somehow manage to cut, so if you can manage to cut
Or, Mama,
hmm
children being
Yes, I noticed that.
eating while looking on. I'm disgusted.
So that one cuts 10, right? Okay, and the bottom one. So the only issue with the bottom one is that it's cutting one square that's the same as the other thing is cutting. Okay, there's two squares or three squares which it's cutting the same square on. But your goal with the second thing is just to cut these lines, yeah? You don't need to cut the top corner. So in this way you can get how many? 1, 1, 2, 1, 2,
Michelle, stop
3.
distracting Caitlin. If you're not gonna learn
I'm just
yourself.
showing her.
Why is it that you don't understand why we don't like you right now? Yeah? Why can't you understand that? So we're trying to do this, and you're doing other things.
She's eating chocolate.
Okay, so 1, 2, 3, 4. So that gives you 14 squares, right? Because some of them are the same. And does it cut? Yeah, so unfortunately these two things here, these all come from the same square. These. So only those other 4 squares are new squares. So I think you'll be able to beat that if you won. Yeah, see, if you don't understand, right? So my policy with people who don't understand is if you were trying the whole time to understand with all your effort, 100%, yeah, then I would try to make you understand more, yeah? But if you're wasting your chance to understand, and then you come to a point you don't understand, right? Then you're on your own, do you understand? Alright, so if we move the red square down a bit, we could beat 14, maybe. Could beat.
How many squares is that now? Do I need a square?
So it's
Wait,
1,
aren't you
2,
double counting
3,
squares then?
4, 5. So that'll be 15, yeah? 15. And that does have one overlap square.
How much squares are inside that square? Because I just draw a square.
I think you just focus on watching, yeah? Stop doing, don't draw. Just think.
Drawing the picture.
You don't need to draw the picture.
But it would be easier because I can see it closer. Well, there's a big screen over there you can see.
Yeah.
I can even see. Why do you need a picture? Yeah. I can even see.
Okay, so I guess what we can conclude from this is that so if we had just two sides of the triangle, okay, then we should be able to get 15 or more, maybe. Okay, we can get at least 15. We can definitely not get 18. Okay, it has to be 17 or less. Okay, and I think we could probably, if we worked it out more carefully, we could show that we could probably get exactly only 15 or 16. Okay, with these two lines, and also that the if we had even if we had the third line, it's not going to be in the middle. Okay, like these two lines are not going to be both like this. Yeah, we know that's not going to be the answer because that won't get you very many, right?
It won't give you any squares because it's just double counting the squares.
No, it's not double counting all of them. Okay, it's still giving you like this one, right? It's giving you. Um, okay, the others are basically the same, so that'll give you 11 squares. Yeah, and if you add the third side of the triangle, it won't give you any more. Okay. All right. So this hopefully will give you understanding, and then I'll show you what happens when you put the third side of the triangle. Okay. So let's erase these things. Maybe I'll just erase everything. Okay, we'll just go somewhere else. So with this kind of understanding,
I draw the picture.
okay, so you imagine on the other side there's like to some point the line going this way and going that way, right? And so what they see doing that is exactly the same thing, but now it's the other way. Okay, so let me just give you an example. So I start here with my triangle, right? And let me use a rule. Maybe so I'll go here. Okay. And then I go like here. Okay.
I'll miss 2 squares.
And then I join them.
That missing 2 squares is that this is 1, 2, 3, 4, 5 squares.
Okay, so can you see how we count the number of squares here? So the easy way to count the number of squares, okay, is just count sort of where they intersect the green lines and the blue lines, and then delete the ones that you count twice, yeah? So this one intersects here, here.
I think I miscounted.
See?
$18.
Is 18?
I should have known it was 18 already. I already did this shit.
Okay, so can you see that there is... Okay, so these two are obviously in the same one, right? These two are obviously the same square. And these two are obviously the same square, okay? You know, it's not completely obvious that these two on the right are not the same square, but let's assume they're not the same square for now, okay? So how many does that give you? It gives you 3 corners, right? And it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yeah? So 4 plus 5 plus 6 is
18.
It's 15, and then plus the 3 on the outside is 18, yeah?
Yeah.
Okay. So it's much easier to count when there's the lines there, because you don't have to worry about so you might not even know which square it is, but you know there's one square from the line. Okay. So can you see how it works? So basically, if so wherever these Michelle, focus.
Question.
You're wasting time on things that are not relevant. Do you understand?
You could just wasting time on drawing that.
Yes. So whatever they taught you in school is not helping you learn this, okay? So if you look at these two lines, right? Wherever they land, okay, the number of blue lines that's in between these two lines, right, is basically how many times the third side is going to intersect. Okay? The only thing you have to be careful is the first blue line doesn't help because it's already going through a square that you've already got. Okay? And the last blue line doesn't help either. Okay?
I drew the question.
So minus the blue lines at the very ends, the other blue lines all contribute an extra square. Okay? So um so the number of squares that the third side cuts is basically the number of blue lines that's in between the other two red lines minus 2. Okay? Does that make sense? It's minus 2. Okay, see there's there's 1, 2, 3, 4, 5, 6, 7, 8 blue lines, right? But the first and this last one don't count because they already got hit by the red line. So there's only 6 it's not 6. Yeah, there's only 6 squares that it hits, okay? So now you should have like a complete understanding of the problem, because what happens, right, is you can vary the line on the left, okay? See the difference, if you move the line to the left, right, what happens is you cut less green lines, right? Because there's less green lines that way, yeah? See, there's most green lines in the middle, like here, right? That's where the most green lines are. But here, there's not as many green lines, yeah? Okay? But if you move it that way where there's less green lines, there's more blue lines in between. Can you see that? You understand what I'm saying?
No.
Huh? So this is where, like, if you don't understand what I'm saying, you got to use 100% of your effort.
The question.
Yeah. Okay. Does it make sense what I'm saying?
Yeah.
So the more green lines you hit, the less blue lines you hit. Yeah?
Yeah.
Okay, and it's the same for this other line. It's completely symmetric. Yeah? Okay. So what I was saying, the more green lines you hit, the less blue lines you hit. That's not a very precise thing to say, right? That's very loose, like very vague. Yeah? What if like every green line I hit, I lose like 3 blue lines, you know? Or if I hit 3 green lines, I only lose 1 blue line, right? Okay. But can you actually see that for every green line I hit, I lose exactly 1 blue line? Okay. Because the green line and the blue lines intersect at the top. They intersect at the top line, right? So
Yeah.
so if I move this red line, yeah, if I move this red line a little bit like over here, right? So what does that mean if I move it over there a little bit? Well, it means I intersect this green line now, right? Which I didn't intersect before, okay? But I also lose this blue line here, which I used to intersect, which I used to have in front of me before, right? Okay? But because the blue line and the green line intersect at the top, I always lose one for every one I gain. Does that make sense?
Yeah.
Okay, so that's the key to the question here. Okay. So if I move it closer to the middle, okay, I hit one more green line, let's say, yeah? So I hit this green line, yeah? So then my number of squares that I cut goes +1, right?
Yeah.
So I hit an extra green line. Okay. But at the same time, there's one less blue line between the red lines. Yeah? You see?
Yeah.
So I go -1 for the blue line. Yeah? Yeah? But overall, there's no change, you see? That makes sense?
Yeah.
And the only weird thing that happens is when the 2 red lines are both close to the middle. Okay? Okay.
There's no change because you +1, then -1 is 0.
Yeah. So then what I'm saying is, so not only is the most squares you can cut 18, okay, is that it's always going to be basically 18. That makes sense? So, and then obviously when you get to the middle, it's less than 18, so you don't have to worry about that, right? So it's only when it's sort of not close to the middle that you have to worry about. And every time you get an extra green line, you lose a blue line, right? Okay. So actually, this is a very interesting question because, well, first of all, on the test, if you just tried it and you got 18 and you just write the answer 18, you get it correct. Okay. But you'd not be sure why it's 18. Okay. So something mathematical was missing. Okay. And this is what we spend the time figuring out. Okay. Does that make sense? So not only is the answer 18, you can basically always get 18 as long as you don't draw something that's going through all the corners. Yeah. Do you have any questions?
No.
Okay, remember what I said. When you're listening to class, okay, try to ask a question, one question at the end of every segment. Do you understand? Try to ask one question because no questions doesn't mean that you understood everything. I know that for sure. And having questions doesn't mean you understood everything either, okay? But thinking of how to ask a question makes you think about what you just learned, okay? Otherwise, you're kind of just watching TV, you're not thinking about it at all, all right? So maybe I'll give you some time now. Maybe you can think of a question to ask me.
I can.
Okay. Let's see if your question has anything to do with this. Hmm?
Why would you always get 18?
Ah, good question. Why would you always get 18? Okay, so what we did was we drew this triangle, okay? Okay? So this is a good summary of what we just did. We drew this triangle, we got 18. Yeah? And then we realized that if we move the edges, so all the other triangles can be gotten from this triangle by moving the edges, moving these points right and left. Yeah, and this one up and down. Yeah? Okay. And then what we noticed is every time we move left, okay, we might cut less squares because it hits less green lines as we go left, right? Okay. But we also cut more squares from the third side because there's more blue lines in between now.
Yeah.
The further left there are. Okay. Okay. So that means, and actually there's exactly one blue line for every green line because the green line and the blue lines intersect at the top. Yeah. They intersect. They intersect on the top line, right?
Yeah.
So as you move past exactly one of each. Okay. So that means it doesn't actually change the number of squares you cut. Okay.
Yeah,
That makes sense?
blue lines are touching every green line.
Yeah. Okay. So it doesn't change the number of squares you cut. And the same with this one, going up and down. Okay. So it'll still be 18. Okay. Um, okay. But of course, there's one consideration is if you get too close to the middle, the squares start being the same squares on both sides. So you get even less. Okay. But we don't care about that because you get even less. You don't get more, right? So if they get close to the middle, the third side doesn't even cut any squares at all, and the other two lines can't even cut 18, right? So we're trying to just worry when they're far enough apart to not overlap, right? That's when they'll get the most squares, and we got 18 somehow, and then we show that it doesn't ever change from 18 even if you move it, okay? So therefore the answer is 18. Huh? You understand?
Yeah.
Okay. So you might think, I don't know, you were in class and we talked about it and then you came away and then you came back and then we talked about it and now we have the answer, right? So you might think that the answer just came magically, right?
Yeah, I might think that
Or
some magic person, bibbidi bobbidi boo, made the answer come out of nowhere.
yeah, or you might think that I just looked up the answers and read the answers from a book, right? Okay. So neither of those things happened, okay? And so what actually happened is,
with your big brain.
so we thought about this problem
With
for
that big
many
brain.
hours, okay? So the first day we thought about it for like an hour.
Yeah.
The second day for like another hour or something.
But we used our
We
big
spent
brain.
like maybe 10 hours on this problem. You understand?
But we used
Okay.
that big brain.
Yeah. Yeah. So and I'll show you the videos, okay? I'll upload the videos as I get you to do the next thing, okay? So I'll upload the videos and you can actually kind of see that, I mean, this kind of thing doesn't just appear instantly out of nowhere. It requires thinking, okay? I mean, in the exam, I always wonder what you're meant to do in the exam because you would never be able to have that certainty, right? But if you actually just drew the triangle, you would get 18. And if that was your guess, you would get it right. Okay, so the fact that the answer wasn't different to the first thing you got make me think that the answer the exam might just expect you to draw a triangle. If you draw a triangle, you get 18, and it'll be correct. And I think there's some other reasons which are less precise that could make you maybe not 100% sure it's 18, but enough for you to write the answer in an exam. Because I don't think you can really be 100% sure in the exam on a question like this with very little time. But I guess it's a good thing that you don't have to be, and they wouldn't want more than one person to guess it anyway. So
I give this question 5 stars.
For the exam? for example, because now it's like 30 squares, and what if they make it 40 squares?
Yeah.
Would they have the same similar question?
I guess
or,
that might be with 40 squares. It might be a bit too hard because
20 squares in.
yeah. I mean, out of all the questions I've seen in AMC,
Yeah.
from like
Is
all
that
the
good?
different years, like year 12 to year 3,
Yeah.
this is the most interesting question I've come across. Interesting
So
question.
has it appeared before, or has
In
it?
2010.
That's the only time it.
So this question, yeah, so this was 2010,
Yeah.
question 30.
Yeah.
Only interesting question.
Yeah.
What's the hardest
So the
question
other,
though?
so a lot of the questions were like even in older, higher years and more recently, the questions were very routine. So like you could do something very formulaic to get the answer, and you'd be pretty sure of the answer just from doing that.
Yeah.
Here, I think we could get 18 very quick, yes?
Yeah.
Because you just draw a triangle, it's 18.
Yeah.
And everything you draw is actually 18, so it's kind of funny. But I don't think you would really feel sure that it was 18 until you got something like this. Or maybe there's another way of doing it. Which I think is good for us because we had a whole week to really think about it.
So there's no formula for this one.
Well, I mean, it's not a standard thing. Maybe like we've just proved the formula actually, so we can actually prove this generally.
So you count the number of green lines and count the number of blue lines and minus 2 is 18.
Exactly.
And if you do maybe 20 squares,
yeah,
and then we draw how many lines?
Yeah, exactly. If we made it as
2.
so, we can actually do this for many grids, right?
Yeah.
What is this?
Because we probably
Can we just every time just add 10 new grids each time we finish the
And then minus
question?
2.
Yeah.
Is that the formula?
Well, we proved it. It is, yeah.
Yeah.
So, and then and it's basically the same number all the time. It's not changing.
Is your brain's big?
I mean, this could be it's not in the syllabus. It could be now. We proved it. So we just that's the beauty of maths, right? What are you doing?
I have a question to see if your brain, if my brain's better than you. What's this?
I don't know.
A pen.
Okay, you're wasting time again.
If you had 20 squares, how many lines, how many blue lines and green lines would you have?
So if it's 5 by 4, yeah?
Yeah.
Yeah, so if we change the question up to...
Changing.
So maybe you start here. And you have... I'll do green first.
Wait, I need the drawer.
I think it's easier when it gets bigger even, because when it gets smaller, it goes closer to the middle, but...
Actually, that is true.
Will be 8 again for blue lines.
Wait, is it minus 10? Minus 5.
Okay,
Yeah,
how do we do
minus
this?
5. Wait, no, it's minus 10. It's minus
8 and 8. So it will be
It's
8
gonna
plus
be
8 minus 2.
Yeah, it's gonna be 8 because it's minus 10. So it's just 8.
So, let's see.
So it will
So
be
green...
8 plus
I know
8
the
plus
answer
6
is 8.
is 14.
It's not 14, it's 8. That's what I think.
No, it's 8 plus 8 minus 2. That's the formula.
Oh.
So you count number of green lines and number of blue lines and minus 2. And that will be the formula.
Yeah, then it is
Isn't it?
14.
So, wait, we might minus more than 2, hold on.
Oh.
So this green line is being counted twice.
Yeah.
Hold on, so we count... So this is 1.
Yeah.
2... I don't know.
Parramatta, New South Wales, Australia.
Spain.
Yeah.
Okay, these are the same, yeah? And then these blue, this is the same, yeah? So it's 1, 2, 3. Yeah, so basically you just -1 for each corner, yeah? So -3 then, I think. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 14. Did you get 14?
Yeah,
Yeah,
14.
it is.
yeah,
It's a formula.
yeah. So I guess we understood a bit more generally then. So yeah, so maybe in some other cultures it's a normal thing, like everyone just seen it before, right? But here it's very weird because um yeah, I guess this would come under also this combinatorics, but in a sort of a geometry setting. Yeah, so I guess the nice thing about our solution is we could do it for any size grid.
Yeah, yeah.
Yeah, yeah. It's very nice, and I think it's very nice. Yeah. Okay, so while I upload these videos, I give you 10 minutes. So let's try to our lesson go to 5:15, okay?
I got the lesson.
So I'll give you 8 to 10 minutes to do the first 20 questions of this paper, okay?
What? What? What?
Okay, don't worry if you can't finish it. We'll talk about it pretty soon.
I got -11. What question is this? Where's the pen? So
2010, this is 2018. Different year.
can I use a pen? 2018
I don't know. Ask your daddy.
Baba, okay, yung pen mo.
Alright, start. Don't waste time. I'm gonna upload the video so you can see exactly what we did to prepare for that question, okay?
Yes, the pen. It's okay.
What is easy? The first one? This is
Alright,
easy.
try not to say it's easy, just do it, okay? You say it's easy for question 1, and then by the time you get to question 8, you're like, oh, I shouldn't have said that. What date was it?
That's 26. 26th of July.
Which of the following is the
27th. I've already uploaded this.
Why is starting so
Okay, let me
easy?
just upload this.
Yeah, they're trying to trick you.
No, not in the first 5 questions. It really is just easy. I think it try to make people feel better.
Okay. At least we
Can't get
do
0.
the easy ones.
Yeah. It's like, in table tennis, how if you're winning 10-0, you just lose the point. You get to 1 point.
Are you doing it? What's 8?
This one.
I don't know.
A, 20 millimeters. B, 25. Calling up the answer.
Shh. Sure, there's people here, don't talk.
I'm not calling out the answers. I'm just saying those A, B, C, D, E. To 200. Baba,
What?
what does diameter mean?
Don't ask that. We'll talk about it when you're done, yeah?
Okay.
You gotta pretend there's no one to ask in the test.
I found the answer. I cheated. I look at the back. What are you doing? Which question are you doing?
Don't talk to people. It's exam.
You only get 17, right?
Sorry. I'm just making a bit more videos.
As a cheat, you can just.
Shh. Resist talking. You only have another 5 minutes, okay?
Closest 最靠近。
There's no. It's rubber. Oh, it might be rubber.
我就想给他们看要怎么用心做一个题，因为你不一定要得到答案。
So you gave me a broken rubber. Broken rubber because too much rubber.
There's no more rubber than that was the only one. Oh, that's not a rubber. I could rub out anything because I'm using a pen. There's a rubber here.
而且我觉得很多人可能都不愿意说他们花了很多时间去想一个题，而且也想不通答案，因为会有点儿就可能怀疑自己笨还是什么那样的。但是我我想表达这个并不是这回事。Yeah, I'll skip to the next one.
门开了。
啊。
门开了。
啊？没开吗？Level 14.
I swear I pressed the button. What happened?
Welcome. Ernest. Oh.
消息网络里面的，我在这边等等一下，好了。
I would spoil it. But then you want to when Dad was just explain that.
You can ask me that.
哎，你在做什么？Ernest, you can either listen to the first 20 questions with us, or you can do the test yourself, and then we'll start when the other people get to. Because the other guys are going to show up. Well, after if you want to do it yourself.
睡了1个小时，正好你们来，他就开始睡。
挺好，挺好。
Hello, 你好吗？你好，我的
Wait, just make sure you know what's on.
你好，妈妈。你好，妈妈。
这是你的 Marisa。
是
你爸爸妈妈的。
但是也是我的梦想，我的宠物。
没事吗？
Okay, almost got it. Almost got it.
我以为下午会睡觉。
Sister, do you
What? Yeah, it's here.
on the couch? Oh.
下午你就住。
Is that the video?
No.
Oh wait, I think that's a different video on class 3. When we were doing the algebra in the shop festival. Where's the part where we explained it? The answer to question 30. There's a shop fence right here. Yes.
Okay. I put this all in this playlist, okay? And I'll give this playlist to Lisa to send to you. This playlist here. Damn. Go to Lisa. Yeah, put it Lisa. It's in your Discord, okay? Damn. 就说你没见过那个 formula，你可以当时证明它。
我以后也学上了，不然我不会，因为就通过那个证明的过程，然后就得到一个 formula。但他不会说你直接就给你一个 formula 啊，就这样子，但你又不知道 background 是什么，多好。
对，所以你有那个能力比那个记住那个 formula 重要。
对，这倒是，而且可以加深你的印象啊。
对，他会用一个方面证明以后会来。
哎，对对。
Alright, let me just